Hello world, Microcats! Today we will manage a smart RGB tape. This is a strip with leads with each LED having 3 color components. Way a connected is series, where this way represent a connected chain. Data transfer comes from the digital port of a microcontroller. And so we connect the STM32 microcontroller, an incremental encoder and an LED strip. In this example we have a tape 1 meter long. In total there are 60 RGB LEDs of a WS2812B type on it. This is a generation of smart LEDs that are controlled by serial control data bits. Each bit is responsible for its own component of a LED color. The tape has 3 inputs: power plus, power minus and control. The control signal is passed through the printed conductors of the tape from the one LED to the next. We turn on the power and see a quick color change. To slow down the color update rate, turn the encoder knob a little. The program receives data from it and so calculates the required delay based on this data. That is, the encoder forms a pause between the LEDs lighting up. A serial dynamic line consisting of 5 LEDs for colors red, green, blue is implemented here. A dynamic line as it there crawls through the entire tape. By choosing the refresh rate with encoder, you can achieve a beautiful LED refresh. Consider the electrical circuit. The master device for the formation of pauses is the encoder. The STM32 microcontroller analyzes the encoder counter and also output a 24-bit code. This code is for smart LED strip control. It is built on series connected WS2812B microcircuits. Let's consider the software part. In the main function we configure the peripherals. We initialize the encoder object. We initialize the smart stripped object. We indicate the number of LEDs. In an endless loop for each LED on the strip, we indicate its color. In this particular case, we create a dynamic 3-color strip with 5 LEDs of each color in it. We use red, green and blue. After a time delay, we shift the strip along the tape from the beginning to the end. The time delay is generated from the encoder signal. There are some tuning parameters for the smart stripped object. You can change them if the tape LEDs are on or behaving unexpectedly. The output of channel 2 of timer 2, configured in the alternative push-pull mode, is used as a control pin. Timer 2 is configurable with a unity divider and PWM operation. Due to the short durations, all work on changing the PWM duty cycle goes through the DMA. DMA channel number 7 works with the selected timer. We indicate the compression register of a second timer channel and the array in which the data for the duty cycle will be stored, equivalent to the transmitted bits to the smart LEDs. To display, you need to start the timer, configure and start a DMA channel. The function to adjust the color of an individual LEDs check every bit, every color component for that LED. If a color bit is 1, when it is necessary to transmit the coded 1 to the smart LED. The coding method is applied on the basis of durations. Coded 0 is a short logical one. Coded 1 is a long logical one. At the same time, we have the same period. That's all, see you in the next video. Subscribe, Microcat.